Alright guys, this is Ashwin here. In this video, we are going to solve the problem down to 0, 2. You are given q queries. Each query consists of a single number n. You can perform any of the two operations on n in each move. If we take two integers a and b, where n equals a cross b, a not equals 1 and b not equals 1, then we can change n equals max of a comma b. And the second operation is decrease the value of n by 1. So we can perform any of the two operations. So if we take two integers means a and b, if we multiply, we will reach n. We can reduce n by taking the max of a and b. So that is one operation, and decrement is another operation. Determine the minimum number of moves required to reduce the value of n to 0. So this is like an optimization problem. We need to find the minimum number of moves required in order to change n to value 0. I'll explain the logic with sample examples. Now let's see the constraints. Q can go up to 10 to the power of 3, that is queries. N can go up to 10 to the power of 6, that is the numbers. Here we can't perform a brute force approach because it will take a long time. Even we can process few queries, but for all the queries like 10 to the power of 3, we need to optimize the problem. Let's see some example. Here we have only two queries. The first query is 3. So for 3, we can decrement 3 by 1 because we can't use 1 other than that. So we will decrement 3 times. So it will take 3 moves. For 4, you can decrement it by 2 because 2 multiplies 2 is 4. So we will take max of 2 and 2 is 2. So it will directly change to 4 to 2. And after that, we will decrement by 1 2 times. So totally 3 moves is required. So they also suggested other case, that is decrementing 4 one by one. But out of those two cases, we are choosing the optimal one. Like that, we have to solve the problem. So from this example also, we can observe that if the number is less than or equal to 3 means, we can just directly return that particular number. If it's greater than 4, we need to do the processing. Okay, let's solve the problem now. Before solving it, we will import a module from math import square root. I'll explain why we are using square root here, because for decrementing the values, we need to use the factors of that values. It's like a prime number or not. While coding, I'll just explain the logic in detail. First, we will do the initialization. So memo equals an empty set. Here we will just store the value and the corresponding counts that it'll take to reach that value. This memo is used to avoid some extra processing while we are doing the logic. And initialize count equals 0. This is the number of moves we are going to take for each step. To implement a queue, we need to import another module from collections import dq. Again here q equals dq of a list, another list. Now n comma count. This is the initial value of the queue, and after that we will go for the main logic. So main logic while queue, if the queue is not empty means we will just pop the front element from the queue, that is n comma count equals queue dot pop left. So we are just popping out the element from the front of the queue. Now we need to check for the base conditions. So base case, if n less than or equals 1, if n equals 1, we will just increment the count by 1. Count plus equals 1. That means we are just one step away from the goal. If it's 0 means we will just break the loop. So in this condition, we are checking for two cases. One is if n is equal to 0, it will directly break the loop. If n is equal to 1 means we will just increment the count by 1, and after that we will break the loop. Now for the general case, we'll just go down. if n minus 1 not in memo, we have two possible operations, right? Decrement by 1 and n equals a cross b. So first we are going for the second operation. If n minus 1 not in memo means we will just add that in the memo set. So memo dot add n minus 1, and we will just add this element to the queue also. Queue dot append n minus 1 comma count plus 1. So after adding this to queue, we will go for the first operation. So this will be second operation, and this will be first operation. For I in range of square root of n comma 1 comma minus 1. So you can observe this execution of range is similar to finding the prime number. We will just start from 2 and go up to the square root of n. I'm just reversing it because we are going to take the maximum of a and b. So if we decrement the values from square root of n to n means we will just get the value quickly. So it will start from square root of n and decrement each time in the iteration, go up to 2. Now for the statement, it is also similar to prime number. If n modulus I equals 0, that means factor equals max of n divided by I, and the other one is I. So you can consider this as A and this as B. We are just taking the maximum and store it in the variable factor. And again, we need to check the condition like this. So if factor not in memo, memo dot add factor and q dot append factor comma count plus 1. So this completes our first operation. After completing all the operation, we will return the count. Return count. So this is the whole logic of our problem. So here we need to add integer because it will be in terms of float. Change it to int. Memo set is used to avoid extra processing. Count is determining the number of moves that it takes to reach that particular number. And Q is to store the number and the number of count it taken to reach that number. And in the main logic, when the queue is not empty means we will just pop the front element of the queue and store it in these two variables. And we will check for the base case if it's less than 1, and after that we will just check another condition. If it's equal to 1, we will increment the count by 1. If n equals 0 means we will directly break the loop. Now we are going for the second operation in the question. So if n minus 1 not in memo means we will just add that number to the memo and add it in the queue also. And for the first operation, we will do this to find the factors like in the prime numbers. We are going in the range in a reverse order. So it will traverse from the square root of n to 2 like we did in finding the prime number. And if n modulus I equals 0 means n divides I is one number and I is another number. So you can consider this as A and this as B. We are taking the maximum of those and store it in the variable factor. And again, if the factor is not in memo means we will just add that number to the memo set. And also we need to add that number to the queue for further processing. Finally, we will return the count. If you have any other logic other than this, please leave a comment below. It will be very helpful for others to follow your logic. Let's run the code now. It passed the sample test case. Let's submit it. That's it guys, we solved the problem. If this video is helpful to you, hit the like button and don't forget to subscribe the channel for future videos. Stay tuned for the next video.